Welcome friends, welcome to the another lecture of structural analysis. We are in the chapter of influence line diagram, also called as ILD. So in the previous classes we have seen the maximum bending moment in section, maximum bending moment under load, maximum positive and negative shear forces, and maximum reaction in the mirror. Now this is the last topic which we are seeing in this, that is absolute maximum bending moment in the girder. So at what load we are getting the maximum bending moment in the girder, that we have to determine. So we know that the maximum bending moment or the bending moment occurs in the mid span of the girder. Okay, so the maximum bending moment always in the middle span of any girder. So what we have to do, we have to divide this girder of 15 meter into two parts equally. So we will put this point as D at the center, so 7.5 meter and 7.5 meter from each support A and B. Now by using Variance Theorem, we will determine the location of resultant. So resultant of what? Resultant of this loading condition. So loading condition are 40, 50, 60, 60 and 20. So if you sum up this all loading condition, we will get the resultant as 230. So where this resultant is situated, that we have to determine by using the Variance Theorem. So Variance Theorem says that the moment of the resultant at any point must be equals to the moment of all the forces about the same point. So looking into that, we will determine this value of x. So x will be equals to 60 into 1.5. First we will take the moment about any point. So any point here we consider this point 20. Okay, so this we will consider 20, and about this point we will take the moments. Okay, so 60 into 1.5, 60 into 1.5 plus 60 into 3, this 60 into this 3 meter distance, plus 50 kilonewton into this 2 plus 3 meter, that is 5 meter, plus 40 into 6 meter. Okay, this total distance is 6 meter. So 60 into 1.5 plus 60 into 3 plus 15 into 5 plus 40 into 6 divided by total resultant. So R we have calculated in total, that is sum of all the downward forces. So this is 230 we are getting. So from this equation we will get the value of x is equals to 3.3. So 3.3 meter is situated exactly situated in the load of 60 and 50 kilonewton. Okay, how we can determine this? This distance is 1.5 meter, this distance is 1.5 meter, total distance is 3 meter, this distance is 3.3 meter we are getting. Okay, so the location of resultant will be in between 60 and 50. So we will just enlarge these two forces only. Okay, we will just enlarge these two forces 60 and 50. Here we have enlarged 60 and 50 kilonewton load, and we will put the resultant at this point 230, and from this 60 kilonewton load this resultant situated is 0.3 meter, because total is 3.3 meter, and before this 60 kilonewton meter load there is 3 meter distance, so remaining distance is 0.3. So we have to put the D span, D, that is the center of any one of the load. Okay, any one of the load from the drain. So for what load we are getting the maximum bending moment, that we have to identify first. So we have condition LHS side and RHS side, we have to compare LHS load divided by span, and we have to compare with RHS load divided by span. So we will just first consider this from D, first load will pass 40 kilonewton. So in the LHS side there will be 40 divided by the remaining the DB span will be 7.5. So 40 divided by 7.5, we are getting 5.33. On left side the remaining load will be 50, 60, 60 and 20. So 20 plus 60 plus 60 plus 50 divided by 7.5, we are getting 25.3. So LHS is greater than RHS. Okay, now we will move this 50 kilonewton load on the RHS side. Okay, same thing we have did in the earlier classes. So we will pass this RHS and we will continue this process till RHS will be greater than LHS. Okay, so we will do this calculation. So this will be 12, this is 18.67. So again LHS is greater than RHS. Now we will move this 60, first 60 kilonewton to LHS side. So this will be 40 plus 50 plus 60 divided by 7.5. We are getting as this as 20, and the remaining value is 20 plus 60 divided by 7.5. This is 10.67. So due to this load, we can say, due to this load we are getting the maximum absolute bending moment. Okay, so what we will do, we will put the center of the girder in between, in the mid of resultant and this 60 kilonewton load. Okay, so what will be this value? This is 0.3 meter. So the center is having this value is divided into 2. So this will be equals to 0.15 and 0.15. So we will again draw the girder AB. Okay, we will draw the center point D. On both sides the distance is 7.5 meter. Okay, so from the distance of 0.15 meter, this 60 kilonewton load that we have to locate, and the remaining distance will be this 50 and 60 meter distance having 2 meter. Okay, so 2 meter minus 0.15, the remaining distance will be 1.85, and rest of the loading condition we have to draw as it is. So 60, beside of 60 there is one load of 60 kilonewton at a distance of 1.5 meter. Beside of that 60, one load is there 20 kilonewton at the distance of 1.5 meter, and beside of this 50 kilonewton load, one load is there 40 kilonewton at the distance of 1 meter. Okay, so this remaining value we have to calculate. This is 4.35 and this is 4.65. Okay, so now we have to calculate the maximum bending moment. That's why we have to draw this bending moment diagram. Exactly below of this 60 kilonewton load we have to draw maximum altitude. Okay, so below this 60 kilonewton we have to draw this one, and we will mark this one as like this. Okay, now this portion is A and the remaining portion is B. Okay, so exactly at center the distance is 7.5 meter, plus this 0.15 we will get the value of B, and 7.5 minus 0.15 we will get the value of A. So we are getting the value of A is 7.35 and the value of B is 7.65. Okay, so we will extend these lines below the loading conditions. So we will mark this as Y1, Y2, Y3, Y4 and Y5 for the load of 20, 60, 60, 50 and 40 kilonewton respectively. So the value of Y3, we know that the value of Y3 is AB by L. A is 7.35 into B is 7.65 divided by L is 15. So we are getting the value of Y3, that is 3.75. So looking into the symmetry of triangle, we will calculate the remaining value, that is Y1, Y2, Y4 and Y5. So Y1 will be 3.75, that is the maximum value at Y3, divided by 7.35. So this 7.35 we will take the part A, because Y1 and Y2 are situated in A side and Y4 and Y5 are situated in B side. So for calculation of Y5 and Y4 we will take 7.65 B value, and for calculation of Y1 and Y2 we will take A value, that is 7.35. So this is 3.75 divided by 7.35 into this 4.35 is this distance. Okay, so 4.35 we will get Y1 value, that is 2.22. Okay, so similarly we will calculate the value of Y2, 3.75 divided by 7.35 into 5.85. So this distance will be 5.85, 4.35 plus this 1.5. So we are getting the value is this as 2.47. Now for Y4 and Y5 we will take this B side. So 3.75 divided by 7.65 into 5.65. So this 4.65 plus 1, we are getting this 5.65. So we are getting the value of Y4 as 2.76, and Y5 we are getting 3.75 divided by 7.65 into 4.65 divided is equals to, we are getting the value of Y5 as 2.27. Now whatever the value Y1, Y2, Y4, Y5, Y3 we have calculated, that value is the magnitude of these loading condition. So for calculation of maximum bending moment, we will multiply this load with the respective value of y. Okay, so we will calculate the absolute maximum bending moment. So 20 into y1, this 20 into y1 we have calculated 2.22. So 20 into 2.22 plus 60, this 60 into y2. So 60 into y2 we have calculated as 2.47 plus this 60 kilonewton into y3 we have calculated 3.75 plus this 50 into y4, 50 into y4 we have calculated 2.76 plus the last load is 40 into y5, so 40 into y5 we have calculated 2.27. So after putting all this value, if you calculate, we will get the absolute maximum bending moment as 646.4 kilonewton meter. So at this point we will declare this the completion of influence line diagram. In the examination, at least three questions are asked in influence line diagram for 13 marks. Okay, so we have covered all 5 variations in this, 5 questions in this. First one is maximum shear force, in which we have to determine maximum positive and negative shear force. Then we have calculated the maximum reaction in the girder at A and at B. Then we have calculated the maximum bending moment in section. Then we have calculated maximum bending moment under given load. And the last one we have calculated the absolute maximum bending moment. So the description, in the description I am putting the links of all the previous video in this, in the video of this one. Okay, go through that and take the benefit of this lecture. Okay, thank you very much.